Hey, let's get started. So, how are you doing? Good? Tired? Okay, so let's continue the database the concept. So today, I'd like to talk about briefly, take a look at the DBMS concept, and then I'd like to introduce some anomalies, insertion, deletion, and update anomalies. Then touch the basic concept, and then we will hands-on will using the MySQL, the workbench. So how to create the database, how to create the table, and then the format that we can insert data, and then delete and drop the table and so on and so on. Okay. So any questions so far? The previous lecture or class? Nothing? Okay. So today, I'd like to mention, I'd like to talk about non-database information system environment. Before using the DBMS, usually we handle the data using the file, similar file and the database, the DBMS system, but there are main big difference. Okay, so briefly, take a look at the non-database the system environment. Then the basic operations, okay, and out the access, the methodology, sequential access, direct access, so on. They have a principle of database concept, just mention, and then the important part is integration and redundancy. So it's a pros and cons. There are trade-off. If we integrate data, redundant increased. But if we separate the data, in that case, the redundancy will be lower, but integration feature will be also lower. Okay, so there are trade-offs. So I'd like to mention that. Okay. My system. The control issue, dependence. Okay, so first of all, before the DBMS or database, the concept was developed. Usually we handle the data using the file. For example, spreadsheets. We can handle, store, save, and then update and delete, and so on and so on. But it's convenient just for the personal data and so on. But think about that, like the company like Amazon or the Google, there are a lot of employees and there are a lot of data, terabytes or size, and so on and so on. We cannot handle using the file. So one of the problems of the data in file is the data was often shared among different programs that needed it, but duplication of the data, like financial department and registrar and what else? Affairs. They should have the students the data, name, address, GPA, MJID, and so on and so on. They can handle, they can store their own version, but student data, financial office, register office, student data, and academic affairs also. It's the same data, student data, but we have the 3 times in each department. So that is the origin of the problem, redundancy, redundant, okay? Then, but this is another the disadvantage is something error, hardware failure or software failure. The file cannot be opened. So at that time, we lost all of the data. Okay, so this is a one advantage. And then secure the vulnerability is another disadvantage. So, okay, so one more, the problem is that here, if the data was stored, change it, the program had to be modified to continue working. If you use the Mac, you store data, the Mac spreadsheet. But if you change it from Mac to Linux or Mac to Windows machine, the Windows or Linux cannot open, what is that? The numbers. We have to convert the numbers data to the Excel or the spreadsheet working in the Linux version. Okay, so that is another disadvantage. We have to change the program every time whenever the data was stored and changed. Sometimes the storage is changed. You have to also change it, the program. We have to redevelop according to the what kind of software, what kind of hardware, what kind of operating system I used. So this is one of the disadvantage. Okay, and just remind to recall your memory. The entity is a thing, an object. Okay, so we want to keep track of. Okay, entity set is collection of entities of the same time. So this is a file. Just think about this is a spreadsheet, the Excel. Okay, and then this is attribute, a property or characteristic of or fact we know about entity. Number, name, city, state, office, commission, percentage, year of hire. Those kind of things are attributes. Okay, you know that already. And another terminology is the record. Record means each row of a structure. Okay, so this row is called the record. Okay, and the columns, example, this is columns. It is called the field. Okay, the file is the entire structure. So record and the field can call the file. Okay. In DBMS, it is called table, or in other words, it is called relation. That's why we can say that relational database. Sorry. The record type is a structural description of each and every record in the file. Salesperson number, name, city, state, and so on and so on. And record occurrence is an actual specific record. These kind of things, the actual data. Okay, there's an occurrence. And then, so four fundamental operations of data are, that, read, insert, delete, and update. So what is called in the 4 letters? Well, CRUD. Create, read, update, delete. It's the same concept. So basic operations, the fundamental operation. So if we have a table or database, you can do that. Read data, delete, update, sometimes create new table, one new database. Okay, this is the concept. Then another one is access, how to access the data. If you store your data, your machine, so the secondary storage has your data. So how can we, for example, read, find, search, retrieve? How your computer knows the exact location. For example, we have a table like that. And then this table is stored in your machine. Then if you want to search the Adams commission percentage, in this case, it's 15. How the computer can search the Adams commission percentage exactly. The computer is not smart as you. Computer is just a machine. So if you save some data somewhere, we don't know exactly, in the secondary storage, according to some algorithm, those data will be stored, saved. But how can you find the Adams, the commission percentage? So in order to do that, the access approach we need. So one access methodology is sequential access. As stated, it is. Sequential means what? It's order, something like that. If you start, for example, this position, sequentially search. Next, 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 or reverse, forward or backward. That is a sequential access. Okay. How about the direct access? What is a direct access? So this is a secondary storage. So there are some data are stored there. Something like that. Direct access means we know the exact location and then go directly that position and then get that data. Okay. So in programming language, in the data structure, the sequential access, linked list, data structure linked list, or the array, right? How looks like array? The array, something like this, and then there is an index, right? So we are able to store the data to where that cell, that element, for example, 10, 20, 30, 40, 50, 60. If we want to try to find, for example, this is a real actual data, and then there is an index. Index looks like an address. So if you know the address, maybe 2, we are able to access directly to this value, right? What is the value of index 2? So go to there and then get 30. If you know index 5, go to there directly and then get 60. This is a direct access. In other words, do you know dictionary? data structure, how it looks like dictionary. In the Python, key value, right? The key and the value. Key looks like the address index, and then this is a value. So maybe 100 Nicole and 200 Christina, something like that. So this is a key and the value, key value. If you know the key, 100, you can get the value. You can access it directly. So this is a direct access way. However, the sequential access, this one is like a linked list. The linked list consists of a node and then relationship. Okay, so like there's a node. And then the first node indicating the next node. And the second node indicating next node. Like this. So if you store maybe 10, 20, 30, and 100, something like this. If you want to search 30, how can you search 30? We have to start from the start, the first element. And then check, this is 30? No, go to the next. Compare 30? No, go to the next. So this is a sequential access. Or you may go to the specific, the middle of the element, and then search 30? Yes. If not, go to the next, go to the next, go to the next, the end of the element. This is a sequential the access the way. Okay. But there are two different sequential access, the physical sequential access and the logical access. So the records are retrieved one after the other as they are stored on the disk device. Okay. In a storage, maybe one more thing. So for the array, the memory are allocated consecutively, physically. This is the first element memory area, and next to the first, the second memory area is allocated. They are consecutively allocated. How about the node? Not necessary. For example, in the storage, node first node is there, and second node is there, third, fifth. We don't know the exact location, can be different, but it's linked, connected each other. So this is a physical difference, the array, and then the linked list. Okay. The same, the physical sequence access is, if you go to the first element, and then what's the next element stored in a disk? Maybe 20. Go to the next, 30, 40, 50, 60, in this order. Physically stored, we are able to access and get the values. But logical sequence access means, for example, alphabetical. I'd like to get the output alphabetical order. So maybe here, this example, the A, Adams, will be first. And then what is the next in alphabetical order? Baker, right? And third, Ariel, and Dickens, and Green, Brinker, and Taylor. Okay, so we are able to get the output in alphabetical order, looks like a logical order, but those kind of data are not stored in this order. So we are able to maybe here and here, Adams and the Baker and Khalil and Dickens and so on and so on. So we are able to search by the alphabetical order. This is logical. Make sense? Okay. Good. Okay. Concept is manageable resource. Just important thing is our data is thought of as a significant corporate resource. The key point of this is what? Share data. We store the data somewhere and then we access the system and we can get, update, create, delete, and so on and so on. Okay, the sharing data is the concept. And then integration, redundancy, I'll talk later. Control issue. Think about that. These days, the Amazon, if we want to buy iPhone 17, so maybe 1 million people I'm trying to access at the same time, right? So just for so simple database, maybe couple of the access doesn't matter, isn't a big deal, but 1 million users, 10 million users are trying to access at the same time to the system. It causes a problem. The server or database DBMS system doesn't support to accommodate those large number of access. So sometimes the data dirty read can be happen. I would like to explain about that. So that is a control issue. So at the same time, a lot of people try to access the specific data. This is a concurrency problem. Okay. System, hardware, software, people. Just keep it. Keep it. Resource. Just to read. Okay. So important concept is integration and then redundancy. What is the integration? Yeah. There's a definition. What is that? Tie together piece of the related data. So for example, one file or one table, there are customer name, address, phone number. In another table or file, sales data about the item the customer has purchased. So if we want to get the contact, if we want to get the customer about the purchased item, in that case, we need a two table. So customer name is in the first file, first table. Then the item history, the purchase history in the second file. So to get the customer about the purchase item, we need those two tables and file. That means integrate two tables, two files. There is integration. What is a redundancy? Redundancy is store more than once. same data are existed in several table, several file. That's a redundancy. Okay. So what is the problem of the redundancy? We need extra space. Just maybe 100 students data doesn't matter. About 1 million, 10 million, 1 billion data or customers data we have to store, we have to manage. If we have redundant of 1 million, 10 billion customer data, we need extra hard disk drive or extra SSD related to the money. Okay, so we need the extra disk space, and then time. The redundant data has to be updated. It takes a lot of time. If you have just one common the data, maybe MGA student data in MGA system, if we have to update data just once, it's enough. However, MGA student data is in the financial department, and then registrar department, and then academic affairs department, your students' data, and here. We have to update how many times? 3 times. But if you have 1 million department, we have to update 1 million times. It takes a lot of time. So 1 million student, 1 million departments, how many? 10 to the power of 12 times we need. A lot of time, a lot of resource. So efficiency is bad. Okay. So, and think about that. If you take a look at the example that I showed, and then I will show just a simple example, maybe just 10 lines and just 1 or 2 tables. But you have to think about the extreme case. The reason we use database system, the computer, is always to think of the extreme case. 1 million students, 1 million department. We have to think the load test related to the load test. So a lot of times, a lot of spaces is related to what? Redundant. Okay. To solve data redundancy problem, we have to come up with the ways, the best solutions. Okay. The integrity related to the accuracy. Okay. So this is our integrity example. We have the 3 departments: sales department, account department, and the credit department. One customer, John, customer number, okay, like this. Name is John Jones, like that. And then address is 123 Elm Street, 123, 123. It's the same. It looks good. But one day, the customer John moves to another house, 456 Oak Street. In that case, we have to update is the data. For sales department file, he updated. It's great. Account, update. About credit department, due to some reason, not updated. this case, what happened? We cannot trust this system depending on which the file we access here and here will have a different result, different output. That means we cannot trust that system. So it is related to the accuracy, integrity. Okay. So I have one question. Take a look at the two table file, salesperson file. There are 4 columns: number, name, commission percentage, year of hire. The second file, customer number, name, salesperson number, headquarters city. So first question is, the salesperson number here and here, sorry, salesperson number in the customer file here is a redundancy. No, why? Yeah, that's correct. The salesperson number can be used to connect, to combine the salesperson table or file. So not a redundant. How about this one? Salesperson number 137. 137, we change the color. Oops, change the color. This one. 137 here, 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 and then here. Is it redundant? Why? So the same reason from the first question. Any other idea? Yeah, the answer is correct. It's not redundant. But reason is a little bit different is the 137 in the first record, this one is related to the what? Custom number 121. The second 137 is responsible for 933. This one 1047. This one 1826. So 137 it repeatedly shown the table, but the fact this one and this one, this record, this row and this row are different. That's why it is not redundant. Okay, make sense? Okay, let me check. Can you hear me? The Macon campus? Okay. So the story, different story. So there are two tables. I'd like to combine two tables like that. This is a customer. This is a customer, This is salesperson, customer number, name, salesperson number, headquarter city. It is from customer file. And then salesperson number, name, commission percentage, year of hire is from the salesperson file, just combined customer and salesperson together. In this case, what do you think? There's a salesperson number and there's salesperson number. Is it redundant? Why? Mhm. Yes, great. So if we want to, for example, if we want to find 121, so the customer of the salesperson 137, so 137 is responsible 121. But there's another way. 137 responsible 121. It's the same data twice. So in this case, salesperson number, the first and the second salesperson numbers are duplicate. In that case, this is the redundant. So that in that case, we have to remove this one or this one to reduce the redundancy. Okay. Then, because of this redundancy, there are three types of anomalies, kind of the issue problem. So what kind of problem? The first one, deletion anomaly. Think about this example. What is the problem? If you delete a customer and the record was only one, salesperson data is gone. For example, customer 2198, which one? That one. Western Hardware is no more the customer, is the general hardware company. So we have to delete Western Hardware from the data table. In this case, what happened? Yeah, salesperson who Dickens is also deleted. But problem is that in this case, the other salesperson, the baker 3 times, Collier 2 times, I beg 1, 2, 3, 4, Adams 1, 2, but Dickens is only one. So if you delete the salesperson Dickens data, also gone from the database, this table. So that is called anomaly. So the deletion anomaly. Okay. Yeah. Yeah. So this is the example that I show you. The redundancy is a problem. Okay. Not actually store the data like this in the DBMS system. Just an example to show the anomalies. Okay. Second, insertion anomaly. Think about that. New salesperson, third, just hired today. So new, the guy should be added to the table. But to add third in the table, we need the customer data. But he doesn't have the customer. So we are not able to add. We cannot add the third. into this table. That is called insertion anomaly. Okay, and then update anomaly. Just set 137. The commission percentage 10 here, second, third, bakers, 1, 2, 3, 4. Yeah, 4. The 4 times repeated. So when the commission percentage increase from 10 to 50, we have to update 4 times. This one, this one, this one, and this one. But due to some reason, one of the data is missed. Maybe 10, okay, 50, 50, 50, not changes, 10. In this case, we cannot trust this system. So it is called insertion anomaly, okay? So there are 3 types of anomaly: deletion, insertion, update anomaly. Because of what? Redundancy, data redundancy in the table. Okay. So in short, there are trade-off, redundancy, and then integration. 2 files, salesperson, customer, are non-redundant. If we have 2 files, one is for salesperson, one is for customer, separate file, or integration, but no more data redundant if you have 2 separate. But in this case, we need a command, multi-command and multiple access using join command in MySQL, the system. But problem is the slow and then error prone. But if you integrate, combine the 2 files, 2 tables into the one, they are integrated, but redundant data can be exist. So there are trade of redundancy and the integration. So what is the goal of the DBMS? Integration, up, 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 and then redundant should be down, down, down. So we have to make the balance between integration and then redundancy when you design your database system, table, and so on. In order to do that, normalization, the scales are used. First normalization, second, third, BCNF, fourth, fifth, and so on and so on, to make a balance. Okay. And software utility. Then another approach. Let's take a look at for your information. You may think, so make a file like this. This is a salesperson and this is a customer, but removing salesperson column, salesperson number column. Instead, I'd like to add customer numbers in the end, the salesperson record, like that. 121, 833, 1047, 1826, and so on like this. You may think those kind of approach to connect salesperson and the customer, but it is not acceptable when you design the table in the database. The reason is that, as I said in the previous class, in a table, in a relation, into the cell, we have to store just one single element, item, maybe like this. So salesperson name, only Baker, Adams, Dickens, Carlyle, only single the atomic data we have to add into the cell. But in this case, how many? 1, 2, 3, 4. But this is a 4 customers are related to the 137. But think about that, 1 million customers. The 137 Baker has 1 million. We have to add 1 million customer numbers in this cell. So not reasonable. In order to find the specific, the customer of the salesperson 137, first we have to search salesperson. After that, we have to go to this column and then search again, 1 million. So it takes a lot. And then, in other words, it is highly variable depending on how many customers in a particular salesperson responsible for. So that is a horizontal solution, not a solution. So one of the idea to connect to tables, but not acceptable. How about this approach? In each salesperson records, we add customers salesperson is responsible for. And next, salesperson, then add third salesperson, and then this is a customer. Fourth salesperson and his customer. You may think like this, but also this is not acceptable. It's very, very difficult to keep track of the data. The columns are, the basic columns are different. It's a salesperson number, but there, what is that? It's a customer number. Totally different attribute, the column. So also this approach is not acceptable. Okay. The security, just take a look at the PPT. Okay. The third, the read, the concurrency problem. So what is a concurrency problem? At the same time, a lot of people are trying to the specific the same data. There is a concurrency. Okay. So one of the example of the concurrency problem is a dirty read. What is this? This account. So initial account value is 500. But so the nickel is the user, and also maybe Christina, so the user. Nickel is trying to update the value to 600. Okay, and then access that the data date 600. In order to finalize update, the she has to commit, means execute the commit command. That means finalize this update. But after change the value from 500 to 600, right after Christina access that account and then check the value of the account. Oh, it's a 600. Okay, so we have the 600. Yeah, the 600. But after that, the nickel, there's something mistake. So I have to keep the 500, not update, not commit. So nickel knows not change the 500. But how about the Christina? He has a long data, 600. Makes sense? But still 500, but she has a long data. That is called the dirty read. There are many examples of the concurrency problem, but that is one of the examples, the basic example of concurrency. Okay. So one last one is just read the data dependence. If storage characteristic of the data had to be changed, the application program had to be modified. It's called dependence. So related to the program and then characteristic storage of the characteristic. But independent means if the storage characteristics of the data had to be changed, not required change in the application of program. So which one would be better? The second one, independent. Okay, so it will be better. Okay. So then, so I'd like to give one practice. Answer. Okay. So please pass to other guys. Here, a file. Let's see. So, who? So, make on campus, I upload the file into the chat. You can download and take a look at the file. Okay, good. No, just one. Oh, you have? No, I'd like to pass the answer maybe 5 minutes later. Okay, so if so, no, you can keep it. Yeah, you are. You have? Okay, and so I'll give her just 5 minutes and take a look at the question and try to answer. Okay, and then compare the answer and then the answer sheet. How's it going? It's easy. See? More two files into one based on which records of one file are read to which record of the other. So means to combine two tables. So you have the answer sheet, right? So this is the answer sheet. The D is just combine two table flight and what? Flight and then airplane file. Okay. So in the left part is from the flight, maybe from arrival time there, arrival time. So those are from the flight, the table, and then the right side, those parts are from the airplane. So just simply combine the table, but due to the limitation of space, the built year is not added, but the built year should be added here. Okay. So do you need any explanation of this? Maybe not. Okay. Or just for your exercise. Okay. And then okay, next is any questions? No? No? Okay. So Mekong campus, do you have any questions? Okay, thank you. Okay, go to the next, the SQL. So relational data retrieval SQL, SQL. So in this chapter, we'll take a look at how to describe, how to create the comment using SQL. Okay, and then there are a lot of the command and keywords. So we'll take a look at then join subquery. What is that? So basically the SQL command consists of four, but depending on the system, five. But basically consists of the four parts: DDL, DML, DCL, TCL. DDL stands for what? Data definition language. DML, data manipulation language. DCL, data control language. TCL is transaction control language. Okay? So like create the drop comment, for example, of the DDL, select, delete, insert, update, a comment of the DML, the grant, revoke, commit, examples of the TCL. Okay, but usually DDL and the DMLs are frequently used. Okay, so if we want to define the data into the system, we use the DDL, definition language. So let's DBMS knows what kind of data, what kind of attributes I'd like to create, define table database. Okay, create, alter, truncate, and drop. And then EML supports the basic operations, the four what CRUD, create, update, read, update, and delete support. Okay, but the command is a little bit different. Select, insert, update, and delete. Okay. The SQL stands for Structured Query Language. It's kind of a standard language for data management system. So a lot of different database system support SQL, Oracle, MySQL, MS SQL, Postgres, and so on and so on, support the SQL. But I'm not sure, but maybe 95%. Most of the parts are same, but only just 5 or around 5%, the comments are different depending on the which or what kind of the database. Oracle has its own comment. So, which means MySQL case, there's a top comment to print only 3 or 5 lists of the data. So Oracle supports the top comment, but MySQL doesn't support top. So these kind of comments, the difference between what kind of the database system, maybe 5%, but maybe more 9% is a common, it's the same. Like select can be used to Oracle, MySQL, MS SQL, and other DBMS. But some of the special comments are not used or used. Okay. So, okay. When you open the MySQL Workbench, your machine, okay. In order to do that, you can type in the search bar MySQL, enter. So this is a workbench. Then, if everything is good, you have only one the instance like that. To remember password 1234. Okay, working. So in order to store data, first of all, we have to create database. So DBMS is database management system. Okay, the DBMS manages a lot of database. Okay, so in the right side, Cape Cod, contact, general hardware, lucky car, rent car, these words, those, each of them is database, right? So first of all, we have to create the database. How can we create the database? You see, create. What is a create? It is a comment from where? DDL, okay? Data definition language. So I'd like to create database. The database name is testDB or whatever you want. Okay. And then when you click the execution button like that, and if you can see the green, the mark, it's good. It's working well. And left side, the schemas, refresh. So you can see the testDB. Too small, I think. So testDB here. Can you see? Right? That means I create the database. Database name is testDB. And then right to use, you have to select that testDB. So there are two ways. One is that you can double click testDB. And then the font is changed to bold. Means this is a working database. Or you can execute use testDB or test database name and then execute. So I select testDB as a working database. So this is we create the database. After that, database, this is a DBMS, DBMS, and have lots of the database, DB, so on and so on. And inside the database, next, tables. We have to create a table. This is a table, table, table. Is how to create a table. So this is example. Create table. Table name is test table, or you can name whatever you want. Like that. Create the table, test the table, the name, and how many attributes here. ID, name, phone number, how many columns, how many attributes. 3, okay, ID, name, telephone number. And then you have to specify the format, the data type, and the size. So the table like that. 3 columns, ID, name, and telephone like this. And we have to specify the data type and the size of each the column. So ID is data type is what? Integer. So you type int. Name is a character, the variable character. And size is what? 100 byte. The telephone, variable character, size 100 byte. And then we have to specify primary key, means I'd like to use ID as a primary key. And what is the non-null? So primary key is very, very important in a table to connect, to find the data in this table. So it cannot be a null. It must have the numbers 1, 2, 3, or 100, 200, whatever, but must not be null. So give some restriction. ID, non-null. This is the option. After write this statement, click execution, and then it's good, which means in the DB, test DB, we create one table, test table, ID, name, telephone number, like that. So in order to check the schema of this, you can use the describe disk and test the table, and then run. You can see the schema you created. So ID, integer, primary key, non-null, name, data type, telephone, data type, but name and telephone can be null. That's why it's a yes. Okay, so we create the database and then we created table, the sample table. Okay, after that, we have to insert data into this table. So about this, we'll continue the next class. Make sense? Okay, any questions? You can save it. So you can use the same example with this. Okay. So the Macon campus, do you have any questions? Okay, thank you. And so that's all today. And then see you next week. Thank you, guys.